Um, so Professor David Sumter, who's in the math department, he's going to talk about a workshop, sort of a culminating workshop of those data science courses on June 4th and 5th. So it's all yours, David.
Okay, thanks a lot. So my name's David Sumter and I work here as Professor of Applied Maths. And in my spare time, or it goes into my work time as well, I also write popular science books. And so I'm just doing a quick advert for a book I've written called Outnumbered. And the book is all about how social algorithms work in our lives. And one example, which the publishers were very pleased about, is that I spent quite a lot of time dissecting Cambridge Analytica. And I looked, could they really use our personalities to understand us? And it turned out, when I looked very in detail at this, it was very unlikely they were ever going to succeed in their stated aims of trying to identify our personalities and target us with adverts. So I've done various things to try and dissect different algorithms. Cambridge Analytica is just one example. I've looked at things like artificial intelligence, machine bias, echo chambers on Twitter, and tried to understand how all of these things, which very much influence our lives, work. And this isn't just an advert for my book. Of course, you can go out and buy it. It's actually more an advert for the following workshop. I haven't written the dates there, but you can go into the website. On the 4th and 5th of June, I think in this very room, we're going to have a workshop where people are going to talk about various ways in which they dissect social algorithms and they understand society using mathematics. So I thought, just to give you a feel, I think the best thing is if I just tell you the titles of the various talks. This is Mira Bernstein. She's going to come from Tufts University, and she's been looking at gerrymandering. That's how you split up different areas so that you get the most of your voters in a particular area and you're more likely to win an election. So they've been using combinatorics to understand this gerrymandering. She'll talk about that. John Murdoch, he's a data journalist at the Financial Times. He's going to talk about race-blind algorithms, which is one of the big questions about algorithms. Algorithms somehow appear more rational in some way, but can they really be race-blind? And it turns out, well, no, they can't. And Julia Dressel has done some amazing work in this. She was an undergraduate student at Dartmouth College, and she looked at the compass algorithm, which identifies if people commit crimes again. And she showed that this compass algorithm was actually no better than asking random people on Amazon Turk. So she's going to show that algorithms, no, I've answered her question now. I shouldn't forget the answer to the question. So algorithms outperform human judgment. Ryan Dunn, he works at Work and Pension, so he's going to have an aspect of how government can use these type of algorithms. Athena Karatazugiani, she has also been working, she's been studying more from a media perspective, how mathematical sociologists start to work and how maths is used in journalism, how we can use this data science. Then Richard Mann, he's been looking at wisdom of the crowds. Can we use the wisdom of lots of people together to make better decisions? Saif Savage has been implementing, she's working in computer science, and she's been implementing methods of having better democracy. So that's very related to the talk before. Revolution stuck on Twitter. That's quite related to me too, possibly. What can data analytics of Twitter data teach us about failed revolution and political change? Can we actually use Twitter as a tool to change the world? Does it actually work after a Twitter campaign? Lisa Charlotte Rost, she's going to talk about how to make visualizations. So this is the question of how to make a good visualization that represents data very well. And Milena Tsvetkova is going to talk about inequality in social groups. So there's a whole kind of range of talks all around this theme of using mathematics to better understand social systems. Go in and check it. That if you're from Uppsala, you can go and fill in a spreadsheet on the SIM, Centre for Interdisciplinary Mathematics webpage, and you're registered. If you're not from Uppsala, I've made an Eventbrite page, so just go in there and register, and you're very welcome to come along. Tea, coffee, and lunch, and possibly the dinner of the conference are all generously provided by the Centre of Interdisciplinary Mathematics. Okay, thank you.
Well, that's good, right? Especially free lunch. I mean, we can't beat that. So, there is no such thing. No, there is such a thing, apparently. So.
Just come to the free lunch.
No, I'm sure it'll be really good. So it's Amelia is our next speaker. You can use the USB.
Okay, you have to fix the alt tab thing.
I mean, you just have to go. So now it goes to OBS. You have to do it twice. But do you need to? Yeah. So you can just go back for.
Do I need the? Okay. So do I need to sit?
You can sit here or sit there or be anywhere. But if you want your face to show, you have to sit here or stand somewhere there.
Okay. Right, so my name is Amelia. I will talk about data protection, but in particular, I will focus on the general data protection regulation, which some of you might be familiar with. If I speak too quickly or if there's something you don't understand, you're very welcome to interrupt me while I'm talking. Also, most of the times when I have talked about the general data protection regulation, it's been with people who are in the middle of an implementation phase, let's say. So they've already actually sat down and thought about what are the implications of this legislation for me, and how will this affect me? And so some of the parts of my talk, for this reason, if you're not very clear on the basis of data protection, or if you don't understand the terminology, just raise your hand and interrupt me, that's okay. It's a fairly legally oriented speech, but I will try to quote the law in a kind of understanding of its societal context. It's a very new law from the European Union. So roughly what we'll be talking about is like, why do we have data protection in the first place? What's the purpose of this law? Where do they come from? What's the historical background? I'm going to show a video from the Hong Kong Privacy Commissioner for Data Protection, because they made this really pedagogic 3-minute kind of animated video about all of the different terms that are used in data protection law, that they kind of make sense, but also it's a lot of specialized language because data protection law over the course of some decades has developed into quite a peculiar beast. Then I will talk about like novelties in the general data protection regulation that enters into effect on the 25th of May in particular. So luckily there's not many novelties in it. So if you already knew the law from before, you should have very few surprises. I will also talk about data protection in research in Sweden and how the Swedish government and Swedish legislation traditionally deals with research issues and themes. Some of the ethical complications of that, whether there could be conflicts with the EU legislation and what could be useful for researchers to think about. And then I'll also have 2 sections with kind of self-study ideas that you can do at your own leisure when you go home, or just in case you find them useful at any time in your life, that you come in contact with data protection legislation and you don't know how to do a particular thing. These 2 things definitely would be useful for researchers to know. So briefly about myself. I am grown up in Sweden. I've studied mathematics at Lund University in 2 different epochs, let's say. So first around 2007, 2008. Then I went to Brussels and I worked with IT and telecoms policy for 5 or 6 years. Then I came back to Lund and I finished my bachelor in mathematics. I've also done cybersecurity and consumer rights research in India. Right now I work with a London-based group called Article 19 on human rights and technical standards. With a particular focus on Wi-Fi and internet protocols. So I've done kind of a lot of different things, but normally in the kind of intersection of technology and law. But so also consistently throughout my professional life, I've focused on kind of consumer rights and individual rights and how to exercise them. So that could be a useful kind of backdrop for whatever I'm saying. So the right to privacy has really emerged kind of in three separate paradigms in the Western world, at least. So the first paradigm comes from the late 19th century, when modern photography was invented. This was also a period of time when governments started to use censuses to map and track their population. They would send out these forms and ask people, what's your income, what's your race, how many kids do you have? And so some individuals, Brandeis and Warren are normally cited as the originating point for this, realized that there was suddenly this potential for technologies that were used to map and track people to kind of reveal them to the world, even when they had no idea that they were being revealed. They focused in particular on photography, so the act of an individual going into a public place, like a square, and doing stuff, and suddenly it was recorded forever. While only 10 or 20 years before that, maybe if you went in the public square and you made a fool of yourself, that would have soon been forgotten. So they constructed this concept of the right to be left alone, or the right to be secret, which means that as an individual, you always have the right not to reveal stuff about yourself. They construed privacy in this way. But also they incorporated in their concept of the right to be secret and the right to be left alone that as soon as you hand over the data, if you say to somebody it's okay to take the photo, if you actually answer to the census form, you've lost control. Then the data is out there. If you reveal the data, that's on you, and you don't have a right to protect that. So this idea was kind of abandoned in the 1970s with the advent of computer systems, and especially their deployment in large corporations like banks, insurance industries, governments, because it became obvious that it's kind of impractical that people have to either keep everything secret or have everything absolutely public. So another guy called Weston coined this idea of privacy rather as a mechanism of having accountability and transparency in how data is collected. So basically taking my picture is okay as long as I know who you are, what you're going to do with it. You might have to get my consent. Also, I should have a consent that can be withdrawn. And I should be allowed to some foreseeability in where that picture is afterwards published. The same thing goes for whatever data the government collects about you in order to kind of put you in a social status profile, or if the insurance company is trying to deduce whether you're a high-risk individual or a low-risk individual. And so this right to transparency and accountability also led to an onslaught of legislation. Sweden was actually at the forefront of this movement. So we were one of the first countries in the world to adopt a data law in 1973, which roughly translated as data law. So it's quite simple. We also have a right to privacy, of course, in the European Convention of Human Rights from 1952, which is inspired by this census movement. So most of the European countries during the First World War introduced massive identification systems for their citizens and identity cards and rations. And then in the 1930s, they were used kind of for tracking down people of various ethnic minorities, and that caused a big outrage. And so after the Second World War was over, and it turned out that identification of individuals could lead to genocide, they introduced a fairly strong right to privacy in the European Convention. But anyway, so data law was put in place in order to give individuals in Sweden a way to hold the government accountable for how it deals with data. Different data laws were also adopted in Germany afterwards, and in 1982, for instance, they also spread into the general kind of European rights framework. And so the European larger area at this time considers data protection a right in and of itself, which is even separate from the right to privacy. That there's, on the one hand, abstract rights to privacy, which include the right to be left alone, include the right to be secret, the right over your own identity. But then you also have a right to data protection, which is this accountability and the transparency mechanisms that enable you to enforce your right to privacy. In the 1990s, there's this third construct of the third privacy paradigm that came mostly actually from the computer sciences, which talks about privacy as a right to control one's own identity. So I, as an individual, have the right to shape my own identity without undue influence from external parties. And we recognize this from Cambridge Analytica debates, for instance, that the basic fear in the Cambridge Analytica case is that somebody will come in, run an algorithm on some data set that they've taken that relates to me, and then they will be able to influence my opinions or the way that I interact with the rest of my environment. There's a really interesting individual called Ager who wrote about this, computer scientist from California. He's worthwhile looking up because allegedly he went underground in 1998 and then nobody heard from him for 6 years. So he's successfully able to escape the surface of the Earth. which I find intriguing. Now, the European Union made the Data Protection Directive in the 1990s to harmonize data protection laws across the Union area because all of the different states had different rules, and that was just economically not very feasible for the Union. But that law, that directive from 95, implemented in Sweden in what we call PUL, or personuppgiftslagen, which roughly translates into the personal data law. They added another classifier there. So that's only in this Western kind of paradigm of transparency and accountability, actually. Now, since 2012, the European Union has been developing a new legislative framework for data protection. This had many different reasons. One of them was that the old laws weren't best enforced. So they've introduced now in the GDPR fairly high sanctions for people who don't follow the law, which is why a lot of people are making a bit upset about it. But also in the GDPR, you do have some aspects where they're trying to incorporate this right to personality, the right to privacy, or the manifestation of privacy as a right to personality and identity. And this is kind of in the implementation phase where we are now. The law enters into effect in 2018 after 4 years of heavy political negotiations. And so if you've been in contact with that, you will probably already be aware of what the mess is. If you want to know more about this paradigmatic kind of story of privacy that I've accounted, you can read the chapter 2 of Seda Gürs's doctoral thesis on privacy enhancing technologies from KU Leuven. It's written in 2010. So I've basically kind of copied her layout and shortened it down a bit, and she has many more footnotes if you're very interested in the history of privacy. I think the history of privacy as a concept also helps you interpret where do these laws come from, like what are they supposed to do and what kind of community context do they arise from. And if you're not really aware of that when you read these laws, and especially the GDPR, they can come across just as large blocks of text that are really incomprehensible and you don't know what to do with them and you become very unhappy. So if you have at you see it as a mission, that the mission of the legislator has been to kind of roughly fulfill this transparency and accountability principle and the right to identity, normally you can improvise a bit and you'll probably be compliant with the law. But that said, I will now try this alt tab trick and see if we can go. So this is a video made by the Hong Kong Privacy Commissioner for Data Protection. It's just cute. So you'll enjoy that.
What is personal data under the Personal Data Privacy Ordinance? Any information which can identify a living person and can be accessed or processed is personal data. Examples include names, phone numbers, addresses, identity card numbers, photos, medical records, employment records, and credit reports. Persons who control the collection, holding, processing, or use of the data, known as data users, should follow the 6 data protection principles to protect the rights of any individuals known as data subjects. The 6 data protection principles cover the life cycle of a piece of personal data from collection, retention, use, to destruction. Personal data should be collected for a purpose directly related to the function or activity of the data users. It must also be collected in a lawful and fair way. When personal data is collected, data subjects must be informed of the purpose of use of the personal data and classes of transferees. Of course, data collected should be necessary, but not excessive. Data users must ensure personal data is accurate and should not be kept longer than necessary. Personal data must be used for the purpose for which the data was collected or for a directly related purpose. It cannot be used for a new purpose unless voluntary and explicit consent is obtained from the data subject. Moreover, data users need to adopt security measures to safeguard personal data from unauthorized or accidental access, processing, erasure, loss, or use. Data users must make personal data policies and practices known to the public regarding the types of personal data they hold and how the data is used. On the other hand, data subjects have the right to request access to and correction of their personal data. If a data user contravenes these 6 data protection principles, the Privacy Commissioner may serve an enforcement notice on it, directing it to remedy the contravention. Non-compliance with the enforcement notice is an offence. An individual who suffers damage by reason of a contravention of the ordinance may seek compensation from the data user concerned through civil proceedings.
Oh. Yeah, so most of the concept in Hong Kong data protection law will actually have direct parallels in European protection law because they borrow their language from the UK, and the UK borrows it from the EU, and the Swedish law, again, is from the EU. We don't call data users users, we call them the controllers. The formal kind of legal term is the controller, but basically you can think of it as a user of data, anyone who collects and processes data. Now,
good question. These 6 principles, are they new for the 2018?
No, they've been there since like the 1970s.
So
yeah.
The 2018 rules, are they, you come to those also?
Are they? Let's see if I'm able to do that. Right. So the GDPR is mostly the same as in the 1970s. Very few things in data protection law has changed. So things like transparency, consent, privacy policies, basically that's still the same as it's already been for 40 years. There's a few novelties in the GDPR, which is the security rules are much more prescriptive. So there's much heavier kind of obligations on a data user to document how they're trying to keep the data safe. There's also better information to individuals. So you have these breach notifications. I will talk about breach notifications specifically in a while, but that's basically for the data subject to be informed if something has happened with the data that wasn't meant to happen with the data. A lot of people are very panicky about breach notifications, but luckily there's lots of good examples out there, even online. And so if you've come in contact with breach notifications and you were worried about them, there's no reason to be. The only new right, substantively, in the GDPR is the right to be informed about profiling. Cambridge Analytica may again serve as a good example there, because what they've actually been doing is trying to profile people's personalities. And so the general idea of the legislation at the European level is that Cambridge Analytica should be able to somehow state to concerned data subjects what is it that they've actually tried to do. They don't need to talk about whether they were successful in whatever they tried to do, but they have to give a brief description of what they kind of did. So, and the GDPR has become mostly known for introducing very high sanctions for economic sanctions for non-compliance. You can be fined up to 4% of your annual turnover. And that's made a lot of companies in particular very concerned. I see somebody with a question, I think.
You talked about Cambridge Analytica, but Cambridge Analytica didn't collect data from the people directly. They asked, like, they went through the Facebook channel. So is Cambridge Analytica responsible or Facebook responsible? I mean, like, if I'm buying data from someone else, that company should be sued or held responsible instead of me.
So the GDPR has several layers of liability provisions for this. First of all, Cambridge Analytica is kind of liable for informing you that they're collecting your data, even if they didn't collect it from you. There's an entire article in the directive only covering that. So the fact that you found out about something that an individual did from somebody who wasn't the individual doesn't let you off the hook. But similarly, Facebook would also be liable for if they hadn't informed you well enough of the implications of what they were doing or what you were signing up for. So potentially both of them could be liable. And considerable amount of time was spent on the preparation of the general data protection regulation to consider how do we distribute liability in such a way that it's kind of fair and that the right people are held accountable and that you get the kind of value chain for personal data that makes sense and where individuals can actually enforce their right. It's a very individual-centric piece of legislation. So lots of it aims at making it easier for private persons or data subjects, as they're called, to actually claim their rights and seek liability from different parties. It remains to be seen for a large part, but how this will play out in practice. This is a law which isn't entered into effect yet. So probably we'll see a lot of interesting case law in the upcoming 5 to 10 years, let's say. And so because some of the data collecting companies like Facebook, for instance, they're basically very big multinationals. So for them, it's not a big deal to push this all the way to the European Court of Justice, which belongs to the process. And so it could be a while before we know the specifics, but the principles of it is still the same, as I said, in the historical kind of layout. So if you're wondering about the implications for your work, you can think of like Cambridge Analytica as a thought frame, because probably you're not going to start the next Cambridge Analytica anyway, so you may not end up with the same problems. Just in Sweden, the government has been frantically trying to implement specific GDPR legislation for the past couple of years. I would say the clarity in Sweden probably is a bit worse than in some other jurisdictions, because Sweden has a fairly sizable direct marketing industry, which of course is very interested in using public records and different informations about private individuals to target advertisements. And we also have very extensive personal data research opportunities based on public registries. So in particular, the government in Sweden has spent a lot of effort in building really big databases over the population that they then either sell out for money to industrial players, or they hand out to researchers for research purposes. And one can have different points of views about this, but it's very clear that the Swedish tradition of kind of research opportunities and maybe even direct marketing is not well in line with the mainstream European data protection tradition that you would find in places like France or Germany. And whether we like it or not, the French and German kind of legal norms dominate the European Union more than the Scandinavian legal norms do. So this is a notice that I was sent by Uppsala University last year after I tried to complain about them handing over my personal data to somebody who was sending me what I considered spam emails. I still receive these spam emails. I've set up a filter now, I think, that just automatically chunks them away, like deletes them. But I was very annoyed that the university has handed out my personal data to somebody who would send me unsolicited marketing about the fantastic offers that they had, because I felt the offers were not fantastic and I don't want to have to manually go over my inbox to sort through emails. That's just a pain. It takes me a lot of time. But the university informed me that back in 2001, a Swedish court had decided that the legitimate interests of an advertiser to send me ads is more important than my right to privacy. So that's basically the situation where the Swedish legislation is in at this time. I would doubt that this could hold up to closer European scrutiny, because it just seems counterintuitive. And this might also cause problems in Sweden, at least in the short term, because we're likely to see these old case law from Sweden being overturned maybe by European practices, and that's going to make a lot of, marketing companies mostly, but presumably in research you could have this problem as well, that people will be upset and they will find, okay, the law is now prohibiting me from doing something that I didn't have to do in the past. So it's just good to be aware of. Sweden is not the most data protection friendly place in Europe, even though we were the first with the data protection law. So what about data protection in research? Well, it's a big field. In Sweden, most of the time when people study this topic, it relates to medical information and medical research. But as we've seen from Simon's presentation earlier in the morning, it could now potentially have effects way beyond that, even in digital humanities. So the first thing is that the research exceptions in data protection regulation, they're exceptions. Each member state can implement them differently. That means that we'll have about 27, or if you count the UK, 28 different exceptions for research, and the rules will be different per member state. So that's inconvenient for researchers that are trying to do cross-border projects. In Sweden, we have the peculiar situation of lots of government registers. There's special government websites dedicated only to informing about what registers you could be put in. You can go to registerforskning.se and check whether you're in different medical registers, at what times you end up in these registries. And they're connected with a bunch of GDPR kind of related issues. that are tricky and where it's not, I mean, the Swedish government has had the implementation strategy of not changing whatever is the case now as they implement the GDPR. We don't know if that's the correct strategy from the government to use, but so that's what they're doing. You have some ethical issues, like do you use an opt-in system for these medical databases or an opt-out system? In practice in Sweden, it's mostly opt-out, or you might not even be able to opt out. So for quality registers for healthcare, for instance, you would normally go to your doctor and your doctor is obliged to put your information into one of these quality registers if you have specific diseases. It's very good for kind of data science and the medical sciences. It's not so good for individuals who want to exercise some amount of control over what happens with their medical data. Frequently in Swedish government registers, you will also find that they're not well pseudonymized or anonymized. So researchers that request data from public authorities in Sweden may find themselves with lots more personal data than they actually want to have. So this could, for instance, be that you get a medical dossier with the full social security number of an individual, their relatives, and their names, even though you were only really interested in some other part of the medical dossier. I have also encountered this problem myself when I was trying to run an experiment on some aspects of criminal law, and the courts just hand out all of these kind of criminal law documents with the full social security number and the full address and names of everyone who was a witness in the court ruling. And that wasn't really interesting for me to have at all, but apparently at the lowest level court in Sweden, they don't pseudonymize. They do it on all of the higher level courts. And so the government could conceivably in Sweden in future be forced to use better pseudonymization practices or de-identification practices in their public data strategies, but they haven't really implemented that now. Peculiar for Sweden, but actually not so peculiar, it exists in many countries, is the use of ethics committees to enable the dealing with of sensitive personal information like criminal records, medical data, what have you, political opinions, even though it would technically contravene data protection law. So then what you do is apply for a kind of permit from an ethics committee that will say whether or not your project is okay and whether it fulfills the data security requirements that could be expected of a research project. They cost some money to apply for, about 500 euros or 5,000 Swedish krona, if you feel more comfortable with this currency. They apply to student projects as well.
I have a research project with sensitive data, so we have this. I would like to have a master student working on data. Do I need to make a new ethical application if I bring in other persons that was originally mentioned in this?
So if they were not mentioned on the original ethics application form, normally you would need to have a new approval for that. That's how I understand the rules and the information that I've been receiving. Yeah, but it's a bit tricky because, as you can see, the ethics committees charge money for application. So they have kind of an incentive to provide this advice. So in the particular case that I was trying to study the behavior of prosecutors. And in order to do so, I had to find out who the prosecutor was trying to represent, like whether it was a company or a private person. And for doing this, I don't need to do who's the prosecuted, like the alleged criminal, but I was given all of that information and then I applied. I tried to get this project published and the publisher was like, yeah, but don't you need an ethics approval if you've looked at criminal cases, because that's really, intense personal data, whether somebody's been the subject of a criminal trial. And in my interactions with the ethics committee at Lund University, I found out that it does apply to student projects. So I didn't do this as a student project, I did it in my free time, but it applies to student project. If it had been a student project, I should have put my supervisor as the kind of responsible for the project and then added my name somewhere. I also found out that the lack of pseudonymization of public documents in Sweden, like criminal records or medical dossiers, is in this case a real problem because it means that people who aren't interested in handling personal data might have to do ethics committee approvals, even though they weren't interested in researching the personal data to begin with. So it does apply to public documents, which is kind of useful to know. Yeah?
But, in my project, we didn't know the name of the incoming PhD students. So their names are not there. We just took granted that, of course, there should be PhD students in the research project, and they were allowed to look at the data search was. So, do you mean to say that I need to make a new one and measure the names of the people?
That's how I've understood the guidance that I was given. Yeah. So you can always ask them, write them an email and ask them if they make a different interpretation. But basically, the way that I understood the ethics committee in Lund, when they were giving advice to me, that's how I understood it. That you know, normally it should be foreseeable in the application who is going to access the data and under what terms. So I think in practice in Sweden, what happens is, which is important with ethics committees to know as well, that ethics committees normally are populated by people who are themselves kind of from the research community, or that are interested in research opportunities, let's say. So they are typically on the side of research rather on the side of privacy, which means if you want, you probably have some leeway, but you would have to then consider, you know, under the GDPR, the risk of an individual in your study being offended by this and maybe seeking some liability for that. So it depends. You can wing it and say, okay, it's obvious that we have PhD students, or you could make the ethics approval. What I think is a bit unfair with the Swedish regulation is that it doesn't apply to non-research. So if you would say that, for instance, we're not doing a research project, we're actually citizen journalists investigating this or that, or we're doing this in our free time, you wouldn't have to have an ethics approval at all, even if you're doing the exact same thing. So in this respect, one could argue that the Swedish rules are a bit more tough on researchers than they are on many other professional groups. And is that fair? But it's one of these processes where, you know, legally speaking, this is meant to give foreseeability to individuals with respect to who is dealing with their data and under what circumstances. And so if you're then saying that I have this undefined group of PhD students that I expect to be coming and going over a large number of years to be working on this project, is that foreseeable for an average person being in the data set that you're experimenting on? I'm not sure that it fulfills the requirement for foreseeability, but I also don't see a practical way of enforcing the right to privacy if one of the data subjects involved would not agree. So, and I'm not sure that the ethics committee would technically file a complaint against it either. So probably you don't have to put the names of the PhD students and pay the fee again. But for ethical reasons, you could.
Take that specific point offline. You have 7 minutes left.
Sure. Sorry. So so it kind of ties well into informing subjects and consent-based studies or non-consent-based studies. So if you're going to inform your subjects that they're being experimented on, how do you do it, and do you do it at all? And this is basically just one of these ethical questions in research that fairly frequently it's inconvenient to inform data subjects because you want to use lots of them, but it might be the decent thing to do. I like to think about data protection as basically at the fundamental level, it's a struggle not to be creepy or not to be perceived as creepy. If you're doing something that you believe that somebody would consider creepy if they knew about it, then probably you should try to be more transparent than if you feel perfectly comfortable that you're not creepy at all. And so just by following that very simple rule, and also defining creepily from the perspective of whoever you're experimenting on rather than from your own perspective, because presumably we all believe we're doing good things, normally you should be in compliance with data protection rules. This is a golden rule that if you follow it, there's no reason to believe that you're not compliant. There are some examples of stuff that people could feel creeped out with. The Facebook emotional contagion experiment from 2013, 2014 perhaps, was not received well by a large number of people around the world because Facebook basically tried to categorize people according to whether they were optimistic about future developments in their community or pessimistic about future developments in their community. And they also found out that if you give people negative news, you can make them more pessimist. And if you give them positive news about the world, you can make them more optimist. So that's the emotional contagion experiment was non-consensual. The data subjects were not informed in advance, and it was widely construed as kind of unethical. You have Cathy O'Neill's Weapons of Math Destruction that I know Raz has already talked about. It mostly has US examples. There's other parallel examples that you can find from Europe. even though European data sciences actually are less evolved than US data sciences at this time. We know about the problem of census and survey fatigues, that lots of individuals who are sought for by researchers to experiment in their to participate in their surveys for there to be an experiment, they simply don't respond. So we know that people are kind of tired of being tracked and mapped just from the fact that if they can opt out, if they cannot be tracked and mapped or not participate, they don't. Except if it's like a short Facebook test, which is what the Cambridge Analytica thing was about, if I recall. So there's also two specific issues in Sweden, which is like the national DNA database has been controversy for like a large number of years. One can look that up or online probably. And also if you ask people how they feel about research, mostly they will say that they want to be informed. So that's an added complication to the life of a researcher, that data subjects in Sweden are typically positive about research, but they also typically say that they want to be informed about what's happening and who's experimenting on me and under what circumstances. So that at least is some indication of what the data subjects would prefer, even if it might not be convenient for your particular research project. So the two examples that I had hoped that you could look at home is the new obligation to do breach notifications. So this has actually been around already for some time. It was introduced in California in 2002 as a way of adding transparency to data subjects when there's an IT security problem. The reason is that data subjects can't control the computers of other people. So whatever happens in your server or in your medical database or in some other database that you're dealing with, that's basically not going to be known by the data subject. So by introducing an obligation to tell people when something goes wrong, a breach notification, security breach notification, you force whoever is dealing with personal data to tell that, and then the idea is that consumers will be able to hold those to account that don't do security practices well enough. It was very successful. It's now in 48 states. 8 of these states have open web archives, so if you've never seen a breach notification before, you can just go online and you can click on these links. I've helpfully collected some links on dataskydd.net/incidentrapporter-exempel, but it's a link that's also somewhere on the Lamastex website, so you should be able to find all of these examples there. You can look through them, see which ones you find pretty, which ones are pedagogic, which ones are not so pedagogic. The idea of collecting public incident reports like this, I have some from Sweden as well, if you prefer Swedish language, is exactly so that you can think, what would I do better if I had a data breach? And I want it to be intelligible to individuals. EU breach notification has also been around for some time. We have it now in 3 different EU laws pertaining to different sectors, because the European way of legislating is a bit more messy than the American sector. Also in the EU, typically breach notifications are not meant to go to individuals. They're meant to go to a public authority so that the public authority can make statistics from them. But if you're into data science and that kind of statistical research, you could consider whether breach notifications is something that you want to make statistics on, actually. That could be interesting. The other thing I thought that people might want to do like beforehand, if they haven't already applied for ethics permits in the past, is just go look at the application form, see what's in it. Imagine for your research project, how would you respond to this? And this is just because if you've already tried to do it once, it might be easier for you to do it again if you ever have to. And that's it.
Please ask Amelia any questions.
I have from David a question.
I have so many questions, but one thing I have to say, so when I wrote my book, I talked a lot to Alex Kogan, who downloaded the Cambridge Analytica stuff. And that don't be creepy rule is what he thought he was following when he created the app to get all of those things. So at the time, he now understands that he was very creepy. But so there is a certain sort of, the bigger question is there a problem with the don't be creepy rule that it has lots of different interpretations?
Well, so one could, it's a rule of thumb, yeah. So the reason that the data protection regulation has 92 articles, which are all extremely messy and contain lots of prescriptive rules, is exactly because there's been a lot of problems historically with companies navigating around the rules or public authorities navigating around the rules. Enforcement hasn't worked well. And so most of the rules in the general data protection regulation are really there to force people who desperately want to be creepy or that just have terrible judgment to have slightly better judgment anyway, right? And that's why the rules end up the way they are. But if you can imagine, if you can imagine the don't be creepy kind of golden rule as more of a way to, like, how would somebody else perceive this? So rather than, do I believe that I'm doing a good job? Because presumably all of us believe we're doing a good job. Otherwise, we'd be doing some other job. We'd be doing something else, right? So we all believe that we're good people. The question is, would somebody else believe that I'm a good person also? If I went to one of the people whose data I was collecting and I told them what I'm trying to do, and I and told them what my project is about, would they then perceive me not to be creepy? And maybe that's more the kind of non-creepiness level that you should aim for.
Because then I wonder, like, what would somebody who was in the Me Too campaign think about some dodgy sociologist from Umeo downloading all their tweets?
It's a very good question. And so lots of these social networks will probably tighten up their API rules now that the GDPR enters into effect, because Facebook has suffered huge PR backlashes from the Cambridge Analytica stuff. Twitter might find themselves forced to sharpen up their APIs as well, because they simply suffer bad will from some of these research projects or like marketing projects that have been around. And so it's not clear to me that after the 25th of May, it will be as easy to do these kind of big Twitter data sets. But that's basically a market response to the fact also that individuals are marking that we don't find this okay. We don't want this to be the way that our tweets are used or our Facebook posts are used. And so...
I mean, I think we should continue with the discussion because I want to chain this. If those who want to leave can leave, but we'll continue the discussion after I explain the mathematical statistics of differential privacy. So what's happening in that space? And also, it's not really clear who's going to be able to enforce a New Zealander who is actually operating on European citizens' data out of Sydney's AWS stack. I mean, these are really crazy technical challenges that I was going to descend into. But I think these are maybe 2 years or 3 years down the road, right? And also when you're doing observational study versus manipulative experiments to understand people, there are, again, very clear interpretations of creepy and non-creepy as well. So I'm going to talk about, originally I was going to talk for a lot longer, but I sort of changed my talk this morning. I'm going to talk about this sort of very big theme of towards participatory democracy in the big data age, right? So this is kind of a recycling of a talk I gave to Engineers Without Borders a while back. So I guess I won't go into this. So we have big data. There is volume, veracity, variety, so on. And okay, it's a lot being recorded for this audience. This part, I don't know how many of you guys know that Microsoft has these data centers in the ocean now. Know this? Like deep sea cloud. I don't know. Anyway, that was cool. But anyway, you have floating data centers. Google's been floating data centers into the Pacific for a while for cooling. So it's called the new oil, right? So this is a corporate pitch talk. So is making prediction from observation new? That's the basic question. No, right? I mean, you've seen the documentaries of chimpanzees, you know, can put little sticks inside like termite holes and eat. And, I mean, that's obvious to appreciate it because we are neurologically much similar to a chimpanzee, but experiments happen all the time through life, right? I mean, if you drop down to chemotaxis, right? I mean, unicellular organisms are constantly have been doing experiments. So making a prediction from observation is not at all new, and within the human tradition, astronomy is a great example. Astronomy is ancient. So this is Brahmaputra, I think, and you know, people from all over the world were doing predictions from observations. So here's the general process for this. The way you can go from an observation to prediction is via a model. So basically there is data, goes through a model, and then the model helps you predict. So in English, you use the past experience as a feedback to improve your predictive model. And of course, I want to emphasize this because I studied like undergrad for 9 years, so I'm really into epistemology, and I speak multiple languages, including non-Indo-European ones. I think there's a non-mathematical class of models and a mathematical class of models, where I'm saying mathematics is an unnatural language defined, in the usual way. So all other human languages are natural by definition. And so usually the mathematical models can be easily implemented as computer algorithm in some computer in the cloud nowadays. So can people see this graph, or should I? Yeah. So basically, you have your models can be very loosely, broadly classified as non-mathematical and mathematical. And non-mathematical models, for example, even from Kathy's book, is cooking, for your family, taking various things into account, and I don't know, household chores, whatever, your sort of worldview, beliefs, and notions of heaven and space-time, and whatever, theology, all kinds of things, right? Kind of can go in here. Of course, you have these more elegant models that are sort of almost built into our germline and culture. So these are multi-generational models, right? Plant and animal breeding is the most concrete instance, right? Everyone loves potatoes, and potatoes don't fall out of the sky. And same with fishing and hunting and all sorts of arts, right? Transmitted arts. So then, of course, in the mathematical models, you have constructive and destructive. I mean, I'm basically using Kathy's. How many of you watched Kathy's TED Talk? Okay, so I'm just assuming you do it. Otherwise, we don't have time, infinite time. So, yeah, and the book is quite good as well. So she talks about this broadly, and I want to emphasize that in constructive models, they generally are scientific. They take feedback from the data. They're always improving, and they usually use direct measures, and they're also transparent and accountable. And then she has a solution for this, which is called model auditing. And Kathy is an interesting woman, right? She's a pure mathematician who went to work for Wall Street. She's a quant. And she kind of done the ropes in the world, right? Like sweating for coding, right? So I really appreciate her insights. Actually, of course, it's unfortunately focused on the American context, but it's not bad. And the destructive ones are they sort of encode destructive biases and opinions. So let's highlight the word destructive for a second. What does it really mean? But it uses proxies instead of direct measurements. There's no corrective feedback loops with data, and usually it's not transparent. Okay, it's IP protected, so there is no way to actually ask for a right to an explanation under this EU law for an automated decision-making procedure that says that my iris is not really conforming to the databases, so I cannot enter the US airspace. I mean, I cannot challenge that algorithm's limits on Vapnik-Chereminka's dimensions, for example, because it's closed source. So it's a real problem, right? And if you look into the supply chains and who's supplying that particular product, and who's if you follow the chain in the US, right? I mean, there's a big conglomerate of VPs who benefit from these sorts of trades. So this is a real problem. So, thanks to von Neumann, right? There's mutually assured destruction. That's a math joke. So anyway, this is the non-mathematical models. This is the highlight, right? So beliefs, how can we be constructive? And to be constructive, I kind of am slightly in a romanticized phase with the Swedish culture. It's my first non-English speaking world. I've sort of moved my family to, is the fourth one. Hopefully I don't want to go anywhere else. So this is this Lagom principle, right? It's kind of a really interesting principle. It's this, whatever. Those who know what it is, know what it is. So I mean, maybe for the guys from India, from YouTube, so Lagom is this idea that the Vikings were sort of sitting around the fire, and they passed some big gourd of some bladder of some sheep they roasted, but they use it as a vessel to drink some kind of beer, and then everyone has to drink a little and be aware of how drunk or non-drunk others are. And so you don't take too much or you don't take too little. That's kind of the principle. So anyway, that's a good principle to ensure some level of constructivism in the model, right? So here's the, so beliefs could be like sexism, ageism, racism, etc. These beliefs actually can get baked into the models. And the really kind of crazy thing is I was working for 2 years for an R&D of a company that was selling software to the security sector, including Interpol various police departments all over the world, and we were doing something called predictive policing, and actually moving into the US market with our algorithms. We were doing very sophisticated non-parametric Hawks processes, which are the same processes used to predict aftershocks of earthquakes. So we will be able to basically minimize the gas expended by the police patrols in certain suburbs of certain cities to actually reduce the burglary rate. And all we did is propagate status quo down to the individual, right? Because I had no idea what I was doing until I kind of read Kathy's book actually very recently. I'm like, because you know, I think I'm saving the world, right? It's a lot of fun maths, and you have access to this amazing amount of data, but you may actually, all you're doing is making a predictive model, and the better the model is, all it's doing is propagating the status quo. If the status quo is coupled by the prison military industrial complex, yes, I'm talking to American, my cousins, you know. So if it is coupled into the prison military industrial complex, and there's a whole lobby group that's actually invested in keeping the status quo, then your software selling to that status quo propagators is just going to keep them going, right? So that's something I didn't realize. So here's Kathy's book. And you know, here's the chapters basically, so I highly recommend reading it. So there's Algorithmic Trading in Finance, and this is actually mind-blowing. University rat race for world rankings, right? Like, I mean, okay. Are there any Americans here? Okay, you know. Yeah, I mean, when I thought, okay, well, if I stayed in the US, you know, maybe for every year I have to buy a Humvee, you know, to send my daughter to, not a top school, an okay school, right? A price of a Humvee. But now it's going to be the price of a Black Hawk Down, you know, helicopter, right? Apache or something. It's crazy. It's out of control. And then if you really read this chapter, you understand what's going on. It's just made up. Okay, online ads, getting a job, performance on a job, predictive policing. This is something I have really deep insights into. Yeah, and you know, this one I'm kind of really getting into the last couple of years. So sort of micro-targeted citizen social, you know, in social media is called opinion engineering, all sorts of things. So I think, yeah, you could have, so that was assigned viewing. So what can we do about it, right? And so I'll try to, you know, get this as fast as I can. So of course we want to fight back, right? Otherwise, what's the point? You know, I don't want to sing the Beck's song, "I'm a loser, baby, why don't you kill me?" I don't want to go there. So of course, you know, David talked about this workshop, which is really great to have a whole bunch of inspiring people that are in the field doing various journalism and activism come and talk about it. So please register for the event if you're around. I myself have been doing something called the Meme Evolution Program. So it started out as a pure mathematical project on what people call combinatorial stochastic processes. So it starts out in mathematical genetics, but now it's sort of generalized to understanding how memes or mental genes. I'm using memes not in the modern internet sense, but in the sense of Richard Dawkins, this Oxford professor. So he construed of memes as mental genes that can evolve in the culture, and there's a lot of sort of partly pseudoscience done about it, but I just use the word. And then we can actually bring in methods from mathematical population genetics and evolutionary biology to actually talk about how memes evolve. Specifically, you can talk about how the exact structure of your, say, transmission network, follower network in Twitter is affecting the shapes of transmission trees, like who transmits what to whom. And so, and then there's a little bit of maths done there. But then I've been spending a lot of my energy on just like coding a lot. Because like Simon, you really need to get into the real world, start sucking in on data, and insights really flow when you actually are looking at data. And this is also Andrew Neg. How many of you guys know Andrew Neg? Okay, so he's the founder of Coursera, famous professor at Stanford's machine learning group. Just recently returned from Baidu, Google Brain and everything. So he says this, he says actually, if you want, and he does mathematical statistics as well. So he says, you know, it's very, very important to play with data at least, you know, half a day per week, even if you're a pure math researcher, because the insights will flow. And this is not something new. Andrei Kolmogorov, who axiomatized probability theory, actually talks about how his insights working with physicists staring at glass beads reflected with light actually gave him insights to the set theory of the sample space, which we'll study in detail about in the foundations course. So this is, obvious stuff. Okay, so I don't want to go into these links right now. So what we later on in the afternoon, I'll talk concretely about this U.S. election study, and then yeah, I guess this was an advertisement for this course. So you guys are already here. So what we are currently doing is, so we have some grants from Twitter and from Databricks, sort of unlimited cloud computing grants, and front-end grants, and then from AWS. So we are collecting data. Already we have around 10 million tweets for the Swedish population. So we're preparing for the Swedish election for September 2018. And so we want to actually build what we call ideological forests for the Swedish population. Well, it's not just Sweden, whoever they're being influenced by. And it's all very simple designs, similar to what Simon is doing. And we'll kind of get into all the primitives of those designs tomorrow. So the idea is, I don't want to be one of the guys that's going to collect data. This is a democratic process. You can do it too. Anyone should be able to do it, and that's the point. Okay. So, so hopefully, where we're going tomorrow, you guys should be able to be your own experimenters. And in fact, that's the point. We want every citizen to be skeptical of every other citizen. That's the only way democracy will work, right? And one of my favorite Americans is Walt Whitman, right? So he said in Leaves of Grass, what did he say? Democracy is the state of minds of the individuals that make up the state. I mean, that's clear. Yeah.
How do you connect these fact that you're collecting data about the Swedish users with the crypto?
Yeah, well, yeah. So I'm getting there. This is the last slide, I think. I'm exactly getting there. Yes, that's why I freaked you guys out. I'm observing all of Sweden. Yes, but we're getting there. So so what I really want you to do is, this book. You should really read this book if you want to be meaningfully associated with ethics or data, because there's a lot more going on. There's operations going on in parts of the World Wide Web that a lot of us simply don't know about. I have some insights into it because of certain experiences I've had in industry. So well, Snowden revelations really make things quite clear, but then what Bruce goes into is simply content as commodity markets. Like, what are sort of operators at the third-party level? Like, there are things called ever cookies. There's a lot going on. So it doesn't matter, if you can hold companies accountable. There's all sorts of entities that can pop in and out, and there's a lot of trade going on in some unregulated sense as well. But even in the sort of regulated sector, like Google, Facebook, all of this stuff, David really goes through, and of course he's a mathematical cryptographer. He's not like some journalist guy. Right? He really knows his stuff. So it's worth reading it. And then I think this was assigned viewing. How many of you viewed this? Okay, so this morning I have 2 minutes, so I knew there'll be lots of slackers. So that's okay. I always do things at the last minute. So.
And we also live in a world where, two caffeine-fueled undergrads at Stanford can write an act that undermines the law, which means that both have to work in order for us to get security again. And this is a thorny problem. What I want people to do when people ask, what should I do? The thing I say is we need to start observing surveillance and talking about surveillance. Pew Research did an international survey on the effects of the Snowden documents. And then one thing they asked is, have you taken any steps to protect your privacy since the Snowden revelations? And they produced numbers by country. I did the calculation by population and percentage, and came up with a figure that 700 million people on the planet have done something to protect their privacy in the wake of the Snowden documents, the NSA's activities. Now, probably most of the stuff people did wasn't effective. Probably some of the people who said I did something didn't actually do something. But what that is a measure of, it's a measure of people's changing their perceptions of data and security based on these documents. I can't think of another issue that moved 700 million people on this planet in the course of a year. That is truly amazing. And what Snowden said is he wanted to start the conversation. I think this proves he did it. And I think we have to continue the conversation. You know, so observing surveillance and discussing it. And it's not a matter of all surveillance is bad. You know, I think this is a complex issue. This is an issue of designing systems to extract group value from our data while protecting people individually. And I actually think this is a fundamental issue of the information age. Our data has enormous value to us collectively, and our data has enormous value to us each individually. How do we reconcile this? Right? What law enforcement will say is, we need to get your data to prevent crime. NSA will say, we need your data to prevent terrorism. And behavioral data is valuable for advertising. Medical data. I mean, there's huge value in taking all of our medical data, putting it in one big database, letting researchers act. Yet it's incredibly personal. Or something as easy as movement data. I like it when Google Maps tells me real-time traffic information based on real-time surveillance. That is a valuable service. How do we extract these valuable group benefits of our data while protecting us each individually? I think this is a very core problem to big data and one we really need to address. I've said this before, but I think data is the pollution problem of the information age. I think it's a reasonably robust analogy. Right? All processes produce it, it stays around, we're discussing secondary uses, recycling, storage, disposal. And I really think that, you know, in the same way that we look back at the titans of industry 100 years ago, 150 years ago, ignoring pollution as they built the industrial age, that we're going to be judged by our grandchildren.
Okay, so I'm going to pause there. That's enough. He almost concludes there. So that's the fundamental problem, right? So he says, let's see. So, and it is not a matter of all surveillance is bad. I think this is a complex issue. This is an issue of designing systems to extract group value from our data while protecting people individually. The sort of mathematical formalism, mathematical statistical formalism of this is actually very, very recent. It's out of Berkeley as well. In fact, there are 2 dissertation awards given, one for Matej Zaharia, who's a Apache Spark we're learning. The second one is for this other guy, right? So this is the latest preprint on Minimax optimal procedures for locally private estimation. So we may start with this after lunch, but I kind of want to point out there is this YouTube video from 158 seconds to 1724 seconds that Michael Jordan very briefly summarizes the minimax theory for differential privacy. It's kind of our first, way to legally enforce something on a data, controller, for example. And then it allows the individual to choose, to tune the knob of what level of privacy you want. And it's actually a very nice asymptotic theory as well. So it's just the starting point, but it's pretty good. Okay, so that's what I'm not working in this area, but I'm kind of tempted to at least read this paper in detail. So maybe we'll present this paper on the Friday, the last lecture. I don't know yet. So I think I'm done. So if we want to discuss, we can kind of discuss for 20 minutes. But if you want to kind of get a bit technical, this one I think is it's really good. It'll answer Matthias' question.
Description of what I think of one of my, say, undergrad students coming out and being asked to do in Silicon Valley. So you arrive on day 1, the boss says, I need a big data system, whatever that will mean. It will replace our classical service with a personalized service. Now I think of these services are going to be data-oriented, so they build a model of some kind. They take in data, and they adjust some parameters, and the search engine does this, and the commerce systems, and so on and so forth. So I want to make that personalized. So most students come out of Berkeley would have some idea how to do that. Well, instead of having one big model for everybody that delivers the same answer to everybody, I'm going to have 100,000 models. And maybe there's hierarchical issues where they share data, handle first day issues, and so on. But I can maybe start to do that if you give me a cloud. All right? But problem gets harder. So in particular, it has to work relatively well for everybody. And in kind of all these systems that do the statistical decision making, you can get the error rates sort of down to to some level, 95% correct or 99% correct, and getting beyond that gets hard. Now, if you're doing that across 100,000 things that are making decisions, that error rate gets to be too large. So if 1% of people are getting bad service on your new personalized service, that's a huge number of people that all go write the newspaper, and your business is going to tank. And so you can't do that. So you have to get the error rates extremely small. And that is a whole new regime in the in the machine learning world. So the student coming out will probably have some trouble already with this. This is called the L infinity norm instead of the L2 norm. All right, so those are sort of statistical model building issues. It's not real computer science yet in some ways, system stuff, but it's sort of not deeply challenging. This next one is deeply challenging, which is that the new service should run just as fast as our classical service. All right, so if you're Google and you've been returning search results in tens of milliseconds, and now you're suddenly doing over 100,000 models instead of one, and suddenly it's slower, people think they've gotten a worse service. They're not happy they got a little better on one dimension, a little worse on another dimension. It has to be just as fast. That suddenly becomes kind of hopeless. So you can start to throw parallelism in it and hope the cloud will be fast enough and try to build your systems better and better. We don't have design principles to do this. Control at L infinity statistical risk, because that's what you're asking to do in bullets 1 and 2, with a temporal budget. Okay, so statistical theory doesn't have temporal budgets in it, and computational theory doesn't have statistical risk in it. Okay, so we're kind of at a loss. You can start to try to build systems and hope it works, but you don't have design principles. And it only gets worse, and this is where it really gets interesting to me, is that it should only improve as we collect more data. It should never slow down. Okay? Because I got terabytes of data today, but I'll have exabytes in the future, and surely that's good. That's the resource that you use to build these machine learning systems. It only can get better, right? But that goes against the grain of computer science. If I have n data points, the algorithms that run on that are going to scale like n log n or square root of n or whatever. They're going to go up with n. So you say, well, I'll throw away the data at some rate, or I'll do approximations. At that point, you became not a really good engineer. You became completely heuristic. Right? The error rate as you start throwing away data points could go up. You don't know. You hope it doesn't. Right? And I think that's actually where we are as an engineering society. We don't have an engineering field of data science. Okay? We have some proto-principles that come out, we put them together, we slap them, we try to build systems. We don't have something to dial in and get guarantees and build a system around. Like I like to use the metaphor of building buildings and bridges. 3,000, tens of thousands of years ago, people were building bridges across rivers, and they could do it, and people went across, and good things happened. But all kinds of times, lots of times they fell down, a lot of people died. Right? And I think we're approaching that era in this field. We build things, but if you have personalized medical decisions to make and you're being given a recommendation where you could die, which is going to happen to all of us, then a lot of people could die. Okay, and if the error rates are uncontrolled, that's something we got to face. And so we're not there yet. And it only gets worse. So many of the people in previous talks mentioned privacy, and there's other externalities, other issues surrounding the system that you're building that people care about. And now the designer, the student, is being asked to bring those to bear in the design of the system. And I hope you can understand. This is a decades-long research. We don't know how to do this yet. All right. So I think about this as being really daunting, and I think it needs a blend of computational thinking and inferential thinking. Okay, so a lot of you will know the buzz phrase computational thinking. Many people are promoted. Jeanette Wayne, most notably in SF, as sort of embracing everything. The breadth of computer science, and I totally believe in that. But inferential thinking has its own 300-year tradition. It embraces lots of things, too, that are a little bit outside of the classical sphere of computational thinking. I think many of the issues you've been hearing coming up in these talks earlier are of that spirit. But how about the sampling pattern that led to the data? Doesn't that affect what we should do? So we debias. Well, that's inferential thinking. Okay? And you don't have to build a brand new part of computational thinking to address it. You can start to bring these two things together. So what do I mean by computational thinking? Well, I mean 61A, or whatever your favorite version of this is.
That's the Berkeley.
What do I mean by inferential thinking? Well, this kind of stuff. Considering the real-world phenomena behind the data, including its semantics, considering the sampling pattern that gave rise to the data. It's not just the data in the database, it's the sampling pattern that gave rise to it. That'll change your algorithm. even if it's the same data in the database, depending on the sampling pattern, your algorithm has to be different. That's inferential thinking, right? And thinking about procedures that go backwards to the underlying phenomena, thinking about error bars. Okay. So how do you solve problems like this? Well, you have to do some math. And I'm going to have a little math here just to show you a couple of kind of the style of equations that I want to aim for in this kind of developing field of rigorous data science. Okay? Now, it's okay to have math here because Dave Patterson, so he's explaining to Armando and me Di Finetti's equation, which is a very deep part
sorry
of
about these little jokes. Okay, just 30 seconds.
You read that picture, Dave. So yeah, the story there is that we were starting the Rad Lab, and a New York Times reporter came in and wanted to have a picture, and so they asked me to write an equation on the board. So I wrote up Schrödinger's equation, one of my favorite equations. And they said, great, what does this have to do with the Rad Lab? And I said, absolutely nothing. And they said, well, write something up that does something to do with the Rad Lab. So I wrote out this equation, which was the exchangeability theorem from Di Finetti. And so then I stood next to it, and they said, no, get this guy looks a little more serious. Get him to explain to you. And so you can try to interpret the expression on my face there, but I'll leave that for you. All right, so part one, inference and privacy. All right, so there were two prizes given, the dissertation prizes given this past couple of years in the AMP Lab. One was Matei, who's hopefully still in the audience, for his great work that's widely known. The second one was for John Ducci, working on privacy. Well, that's widely known. So one of the things we got to learn on the machine learning side of these joint projects is sort of also how to get our ideas out there a little bit more in the spotlight. Because I think we have to build solutions to some of the problems that have been talked about. All right, so the problem's kind of been set up by some of their talks. People are generally not willing to use their private data without some control over it. Now, it's not going to be a 0-1. You can have my data or you can't. If you want my genome, which I have, I'm going to ask you, well, what problem are you trying to solve? If you're studying a disease that runs in my family, here, have it. If you're trying to use it to set insurance rates, then maybe I'll fuzz it up a little bit, but not too much, because I do think it's important to set a good insurance rate. If you're just using it to sell me something, then I'm going to no. So I need a knob that'll allow me to turn that, right? And so fields like differential privacy provide those kind of knobs. What they haven't done is then put that in the context of a machine learning system. If everybody's setting their knobs in certain places, how does my overall accuracy go down? It will go down if everyone's fuzzing up data in some sense. Right? That's the thing that needs to be studied. So I'm going to try to bring this home with a really simple set of diagrams. So I'm a classical database person at this point. I've got a database, say, of banking information. I've got people's age, height, weight, and stuff, and how much they have in my bank. And I run queries against that data, right? It's like who has the most money and what's the median account size and all that. So the query comes in, and out comes an answer, which I'm going to call in this weird language, Greek symbols, theta twiddle. All right. The theory of differential privacy is one version of a privacy story that's emerged, where you define stochastic operators, Q, that privatize the database. In some sense, they add noise to the data, such as you can make certain guarantees that I can't say with high probability if someone's in the data or not. That's a kind of example of guarantee you can make under differential privacy. And you can put in the exact same query to the privatized database. You'll get out a different answer, of course, but you can prove that theta hat would be close to theta twiddle under all queries in some family and under all databases. Things like that can be proved in that theory. All right, so I view this as a beautiful example of computational thinking, but I wouldn't view this as inferential thinking yet. Okay, even if you run statistics as your queries, like find the median, I don't think this is inferential. So think, what's an inferential example of this problem? Forget the banking example and think about a medicine example. Suppose this data is people's age, height, weight, and blood pressure, and I gave them a treatment, a drug, or not, and how much time they lived. That's in my data. Okay, so that's a typical medical database. Right? Do I want to privatize that data? Well, sure. I want to keep people's privacy. Right? Do I necessarily care about the exact people in the database? Do I care about who has the most money, like in the banking example? No, I want to use this data for future people coming into my office. In fact, imagine all the people in the database are dead and gone. Right? In the banking example, it'd be kind of useless, maybe archival data, but it's not very interesting. In the medical example, it's perfect. It's used all the time. There's all kinds of databases full of good medical data. People are dead and gone. Because I'm going to use it for someone else who comes into my office tomorrow who could have been in the database. And as soon as you said words like could have been, you're doing inferential thinking. All right, so here's inferential thinking. A query comes into a database, out comes an answer. And behind the data, there was a population of possible people who could have been in the data, and there was a sampling pattern I had to think about. that gave rise to the particular database. And I want to be able to put in a query to the database, sorry, to the population, and get an answer theta. And what that really means is asking about someone who wasn't in the database who could have been. Now, the field of statistical inference exists, 300-year-old field, that does things like proves that theta is close to theta twiddle under all P's, under all queries, and under particular assumptions on the sampling pattern. So that theory exists. And I hope you can see where I'm going now. We need to blend the two, because now I want to be able to say, here's a picture in which I've got actual data in the database. I want to privatize that because I want to protect the people. I make guarantees to them. They may be dead and gone, but their family may still care. But I don't actually care about the people in the database. I care about the population they rose from. And so I want to say that theta is close to theta hat. I don't even care about theta twiddle at all. I want to say that theta is close to theta hat with high probability over all queries, over all P's, over all S's, and for particular choice of Q. Okay? So doing that is powerful. If you can do that, we have sort of the emergence of a proto-discipline of private data analysis. Okay, so another dictum that Dave may or may not have given, how do you be a good research professor, is that you pose a problem, and then you announce very loudly to everybody in your research group that it's really too challenging to work on, and no one should work on that. All right, so at Berkeley, now other places you shouldn't do that, but at Berkeley, so I did that, and John Ducci was one of our great students in the camp lab, said, okay, I'm going to work on that. And he did. And so we have a JCM paper, and there's some bunch of papers coming out, that I think it was one of the great achievements of the camp lab. And it's not nearly as well known, but it is. It's a mini-max theory of private data. So that doesn't sound as short and sweet as a four-letter acronym. We got to work on that. It exists. All right. So let n denote the number of data points, v the dimension of the parameter space, and alpha the differential private parameter, the knob I alluded to, which I didn't explain. Here's an example of a theorem that we proved. There's a privacy-aware minimax risk. In statistics, the minimax risk is the thing you try to control, the thing you care about. It's the same as the classical minimax risk. If we take the original number of data points in, we multiply it by the square of the privacy parameter divided by the dimensional space. That law occurs in problem after problem. So we propose this as a new law for private data analysis. Right? And you would now be able to use this as a designer of a system, because you go at somebody and says, here's the problem I'm trying to solve. It's the disease runs in your family. I want your genome. And they say, okay, well, my alpha parameter will be 0.5 for that problem. And we have to learn about that parameter. It's like credit card risk. We have to learn how risky it is and how safe we want to be. So I set it to 0.5. That to me means something. So I said, okay, 0.5 squared, that's 1/4, and the dimension on my data, is some number. All I got to do to get the same risk is to have 4 times as much data, because the alpha squared is the 4th. And the designer system would just say, okay, fine, you set the privacy square of that. I just gather 4 times as much data, and my boss is happy because I got the same risk, and I protected people's privacy. So, that's just an example of the kind of thing you have to do. And in this particular domain, we have, a theory of that. Let me show how this can actually cash out into real procedures that you can really run on computers. So here's an example where people come into hospitals and they abuse various substances. This person abuses alcohol and cocaine. And imagine in the population of all of San Francisco, there's 45% of people abuse alcohol, 32% cocaine, whatever. Let's imagine that's the truth.
All right, I'm going to sort of pause this because you can watch this video. It's called The Data Science Revolution. And it continues with very concrete examples of Laplace noise not being good and blah, blah, blah. And there's a whole set of interesting papers coming out of this. You can look at this one from 2017 in the archive version 4. This is for the mathematical statistics researchers. There are a couple at least here, right? Okay, that's good. So anyway, to me, math stats is kind of the bomb, right? Because I did my PhD in the math department. And I did mathematical statistics. And to me, it's very interesting and beautiful because I don't really care about what you think. I care about what you do to the reality that I coexist in, right? So this is called decision theory. It's a very beautiful theory from the 1920s, Wall's decision theory. So it's kind of usually the place where a lot of the things happen. Like, for example, a lot of the regulations with health, Food and Drug Administration in the US, these are all statistical procedures that are enforced as a regulation on what you can do with your drug experiments and things like this. So statistics is interesting because it's always kind of at the intersection of law and empirical sciences and engineering and mathematics. It uses mathematics a lot. Okay, so I thought we have like 7 minutes, so it's kind of a rush, right? This should be a whole semester course. But just what we covered between me and Amelia. But I thought we can now maybe have discussions for 5 minutes or so, and please ask away any questions. to Amelia as well. Yeah. Yeah.
Still, I'm not sure I got the answer to my question.
Yeah.
How do you connect the fact that you are
collecting data?
Millions of people,
well, so you have a Twitter account, right?
Yes.
And you said I agree before you got the account?
Yes.
Okay. So you're following Twitter user rules? Have you read the Twitter user rules in detail?
Not sure what.
Okay. So anyway, and I'm a Twitter developer, and I'm following Twitter developer rules. So that's actually assigned reading for tomorrow morning. So right now, I'm following law as a citizen who's on a work permit till the end of the year in this country. I'm following the law.
Point of view of that.
No. Well, just let me finish for one sec. So, so anyone can collect this kind of data, right? And I will show you tomorrow how trivial it is. Then let's come back to feeling creepy and all this. That's a different issue.
So the recommendation to not be creepy would not pass in the court of law. If you were sued by somebody who said that was fine, not to be creepy, there's a risk that the court will not accept that argument on its legal merits. It's just a rule of thumb to make it easier. But that said, I wanted to say that there's some interesting research by Alicia McDonald and Lori Craner from, I think they're at Stanford or Berkeley, and they've actually looked at user agreements and how much time it would take on average for an individual per year if they actually want to read them, whether this is feasible, and that's all based on kind of American consumer law and American consumers. Essentially, most users aren't aware of what they sign. So on legal footing under Californian law, Twitter is allowed to hand over your data in tweets to researchers, and you've approved of them doing so. So it's kind of a legally stable situation for them. Now, is it an ethical situation? We could argue, and how does it apply under European law? Because typically under European law, consumer contracts are very short, whereas in the US they're very long. But there was recently a research project approved by the Handelsbladet for, I think it's a 5-year study of 14 million kronor that they will be looking at, I hope, some of the Lori Craner-esque type of things. And if you're in particular interested in kind of consumer information related to privacy, Lori Craner is by far the most advanced researcher in the world. She has some very nifty YouTube videos as well.
Yeah, and also, are you comfortable with Facebook owning everything? I mean, Twitter at least makes it open for developers who follow the rules, right? Just saying. These are issues I don't want to get into, and in fact, in my talk, you will not see even one tweet I've collected. You will only see mathematical expressions of objects, and it's just pure research. So I'm definitely following Twitter developer rules. I am also not interested in selling anything to anyone. I'm not interested in active opinion engineering, but I'm definitely designing my systems to monitor for opinion engineering, because I am interested in that. That's part of my research questions, right? So, but you need to read Twitter developer rules before having a sort of meaningful debate today. And yeah, but everyone does this, right? Everyone collects in Twitter, and I mean, if you're into like sort of saving the world from terrorism, for example, my first study was actually on ISIS mention cascades, right? It's public. My home address is public, so what I'm doing is not illegal. How does ISIS simply remain in the public sphere, right? They keep deleting their accounts. I mean, I don't know how much you know about anti-terrorism studies from the US point of view. So, so anyone can, so ISIS obviously, when it was doing well, was monitoring Twitter to do their own recruitments. These are well-known studies from the CTC West Point, right? Counterterrorism Center. So there is obviously a large group of community that does this kind of research, it's been doing this kind of research, and Twitter was set up to facilitate this kind of democratic co-monitoring, right? So how this affects GDPR and all of this? Well, if someone sues me, they can sue me, but I'm not making anything public. So like, if you publish a tweet you collect, that's a violation of Twitter developer rules, unless you present it in a certain way with so these are things I'm following, right? The rest is, I mean, so the objects I'm showing to you are population ideological forests, which I'll define this afternoon. They are like every leaf of that forest is an individual Twitter account. It has some meaning, right? And I'm not presenting any tweets or any kind of personal information. You see, so you have to hide under levels of confidentiality, but But of course, if the differential privacy thing really kicks off, and we are so far away from social media research on how to take these, results from Berkeley and customize it to a particular problem of not being felt creepy by a certain nation within the EU. And this is a long-term project, right? What should the alpha be? In what context? I don't know. What's the theta hat and theta tilde? There's a lot more debates mathematical debates that need to be done first, I think. I don't have the answers. All I'm saying is I'm trying to be really paranoid. I've always been paranoid since I was born, so I'm not violating law as far as I know. Okay, so maybe we should have lunch.